Hello and welcome back to the show. I am absolutely delighted about today's episode because I get to sit down with someone I worked alongside for a good chunk of my career. A genuinely exceptional engineer who has shipped production systems across more stacks than most people have had hot dinners. We are talking backend systems, AI pipelines, cloud architecture, the works. Today we are going deep on microservices, 18 of the most important interview questions you will face if you are going for a senior backend or architect role. Joining me is Oguz Koroğlu. Oguz, fantastic to have you on.
Adam, great to be here. It has been a while, hasn't it? I think the last time we were in the same room, we were arguing about whether go to async or sync on a particular painful integration, and neither of us wanted to back down,
I remember it well, and I believe we were both right, which is the most annoying kind of engineering disagreement. For anyone listening who does not know you, give us the 30-second version.
Sure, I am Oguz. I have been building software professionally for over 20 years now. Most of my career has backend, long running in .NET world, then gradually the Python and AI side of things picked up. These days I split my time, freelance CTO work, AI integrations, and a YouTube channel where I talk about production engineering, and I try to keep things real. No tutorial demos, actual production patterns.
Love that. And that is exactly why I wanted you on for this episode, because a lot of people can recite microservices definitions, but you have actually lived through the consequences. So let us get into it. First question, the classic opener. What are microservices?
So, at the core, it's an architectural style where you decompose an application into small, independent, deployable services, each responsible for one specific business capability. Each service runs its own process at its own data store ideally, and talks to others over the network, usually HTTP or a message queue. The key word is independently. Independent deployment, independent scaling, independent failure. That is the whole promise.
And the classic follow-up, which trips up a lot of candidates, monolith versus microservices. When does a monolith make more sense?
Almost always at the start, honestly. I have seen so many teams jump into microservices on day one and spend 6 months building infrastructure instead of product. A monolith, it's simpler to develop, simpler to test, simpler to debug. The point where microservices earn their cost is when you have teams that genuinely step on each other. Deployment coupling, scaling, bottlenecks that are specific to one part of the system, or regulatory reasons isolate a particular service. If you are a team of 5, you probably want well-structured monolith, not 12 services.
That is a much more nuanced answer than most candidates give. Speaking of cost, walk me through the main challenges people underestimate going into a microservices architecture.
The big one that bites people hardest is data consistency. In a monolith, you have one database. You wrap everything in a transaction, done. In microservices, you have no global transaction. If payment succeeds but inventory update fails, you have a problem. And you have to design your way around to it with patterns like Saga. The second one is the operational overhead. Suddenly you need distributed tracing, service discovery, centralized logging, per service CI/CD pipelines. The third, inter-service communication. You are now dealing with network failures, timeouts, versioning. Things that were functions calls are now HTTP requests that can fail in a dozen ways.
Let us stay on communication. Let us stay on communication because this comes up constantly. How should services talk to each other, and when do you pick synchronous versus asynchronous?
My rule of thumb is, if the caller genuinely cannot proceed without the answer, go synchronous, REST or gRPC. If the caller can move on the other side, just needs to know something happened, go async. Kafka, RabbitMQ, whatever fits your stack. The mistake I see is people defaulting to synchronous calls everywhere because it feels familiar. And then you end up with a distributed monolith where everything is tightly coupled in time. If service A calls service B synchronously and B is slow, A is slow. If B is down, A is down. Async decouples you from that. I have used Kafka pretty heavily on the trading platform. The producer fires and forgets. Consumers process at their own pace. And whole system stays responsive under load.
Brilliant. Now, there is always an API gateway question in these interviews. What does an API gateway actually do, and what does it not do?
The gateway is your single entry point, routing, authentication, rate limiting, SSL termination, everything. It is where you put the cross-cutting concerns that you don't know what to duplicate in every service. On AWS, I have used API gateway a lot, also Kong. The thing it should not do is the business logic. I have seen teams put complex orchestration in the gateway and it becomes a nightmare. It's hard to test, hard to version, and suddenly it is a bottleneck now. Route and authenticate the gateway, leave the business logic in the services.
Great boundary to draw. Now let us get into the resilience patterns, because this is where senior candidates really distinguish themselves. Circuit breaker, explain it, and have you ever actually had to implement one?
Yes. And the first time I really needed one was on a service that was calling a third-party payment provider, you know? When the payment provider had latency spikes, our threads all pile up and waiting. And eventually our service would go down, even though it had nothing wrong with it. A circuit breaker tracks failure rates on that outbound call. Once failures exceed the threshold, say 30% over 10 seconds, the circuit opens and subsequent calls false immediately without touching the downstream service. After a timeout, it goes to half open, lets one probe through, and if that succeeds, it closes again. Poly in .NET, it is a good library for this. For example, for Java Resilience 4G, there are lots of examples. The key insight is sometimes the kindest thing you can do for a struggling dependency is stop calling it, huh?
Love that framing. Now the Saga pattern, this is a tricky one for candidates. What is it and when do you actually need it?
You need the Saga pattern anytime if you have a business transaction that spans multiple services and you need to maintain consistency without a distributed log. The classic example is an e-commerce order. Reverse inventory, charge payment, dispatch order, 3 services, 3 databases. If payment fails after inventory is reserved, you need to release the inventory. That is a compensating transaction. A Saga is the sequence of those local transactions with their compensations defined upfront. Choreography means each service listens for events and reacts, good for simpler flows. Orchestration means a central coordinator tells each service what to do. For example, better when the flow is complex or you need visibility. I have used both. Orchestration is easier to debug because you see the whole flow in one place.
CAP theorem next. A lot of candidates recite it without really understanding what it means in practice. Give me the real-world version.
The real-world version is network partitions happen. You cannot avoid them. So you are always choosing between consistency and availability during a partition. If you are using a CP system like Zookeeper, during the partition some nodes may refuse requests to avoid returning stale data. For example, you are consistent but unavailable. If you use an AP system like Cassandra, during a partition you can still read and write, but you might get stale data, available but not consistent. The interview trap is that most databases do not sit cleanly on extreme. What actually matters in practice is what your tolerance for stale reads and what is consequence of duplicate write. Answer those and database choice mostly follows that choice.
Distributed tracing. What does it actually tell you that logs do not?
Logs tell you what happened inside one service. Distributed tracing tells you what happened across the whole request path. If a user request goes through the gateway, then the order service, then the inventory service, then the notification service, and it takes the 3 seconds total. Logs will show you each service internal timing, but you cannot tell which hop ate the time. Distributed tracing propagates a trace ID across all those hops, and you get a flame graph showing you exactly where is the latency. I have used Datadog for these AWS projects, and it has saved enormous amounts of debugging time. The other thing is shows you tail latency. Your median response time looks fine, but your P99 is killing users, and you need tracing to fight outlier service.
We are nearly at the end. 2 more patterns I want to cover. The bulkhead pattern, which a lot of people have not heard of.
The name comes from ships. The watertight compartments that stops one flooded section from sinking the whole vessel. In software, it means isolating your resource pool seat dependency. Instead of having one sharded thread pool for all outbound calls, you give each downstream service its own thread pool. So if the recommendation service starts hanging and fills up its pool, the payment service pools is completely unaffected. Combine it with a circuit breaker and you have 2 layers of protection. The bulkhead contains blast radius while circuit breaker stops the call once failures are detected.
And finally, idempotency. Why does it matter so much in distributed systems specifically?
Because in a distributed system you will retry things. Networks drop. Timeouts happen. Load balancers retry on failure. If your operation is not idempotent, meaning applying it twice has same effect as applying it once, you will get double charges, double records, double orders. The classic implementation is an idempotency key. The client generates a unique key per logic operation, sends it to request header, and server stores that key after processing. If the same key comes it again, return the original result instead of processing it again. It is not glamorous, but I have seen the consequence of not doing it. Duplicate band transactions are not fun to explain to users.
Oguz, this has been fantastic. You have covered 18 questions with actual production context behind every answer. Where can people find your work if they want to go deeper?
YouTube. The channel is Beyond the Developer. We are hosting in this channel, where I post production engineering content including full microservices architecture masterclass. GitHub is OGU83. And if you are building something and want a senior engineer eye on it, I am on Upwork as well. Always happy to talk architecture.
Brilliant. That is Oguz Koroğlu, 20 years of production engineering wisdom packed into a single episode. If this was useful, share it with someone who is preparing for a backend or architect interview. See you all next time.
Thank you, Adam. Please, guys, don't forget subscribe and like this video.